before I start with the concept of what is row decoding, okay, let's first try to understand the concept of word. So basically, right now, what I'm saying to you is that I have a structure something like this, the one in which you are seeing a rectangle, and in each of this, this rectangular box, this rectangular box, okay, is holding one bit. Now, this one bit can either be 0 or 1. I don't know yet, but here I say I'm storing a bit in this box, okay, in this box, and this box, okay, it can either store a 0 or 1, okay. Now if you see, I have so many boxes. So right now, how many boxes? Please be very careful. When we talk in memory, we always start with 0. So 0 to 1, 0, 2, 3. So how many boxes do I have here? I have in total 1024 boxes. Okay. Now each of this box is defined as a word. And right now each word is holding in each word is of just one bit. So how many boxes? 1024 boxes. Okay. In one box I have how many bit? I have one bit. So in 1024 boxes I am storing how many bits? I am storing 1024 bits. I hope I give you a clarity. Now how do I access? So if I want to have, okay, if I want to know what is the value stored in this particular box, I need to access it, right? I need to access this particular box. So from where I'm going to access this box? Okay, now to access this box, okay, some control signal has to be given from outside, okay, and then the data, okay. So the data has to come, it will come out. Now please see to this. When I talk in this box, okay, so it's just like your lunch box. You can put your lunch inside your lunch box and then you can eat it, and you can take the lunch outside. Your whatever is stored, whatever you have kept in your lunch box, you can take it out. In a similar fashion, in this particular box, I can either input a bit, that is to say I can write a bit, or I can take out a bit, that is to say I can read a bit. So I can, there's an output and input which is going from here. Now what are these? Okay, these are the word lines which I am using to access this box. So how do I access a box? So right now, if I want the value which is stored in B0 to be out, so I need to connect it. Okay, I need to send a signal which is coming from this particular line. Okay, so let's just see. So this is a switch. Okay, this switch goes. Okay, and then as the switch goes, the value of B0 will be out. B0 will be out. Fine. Now this is removed. Okay, I have got the value of B0. I can even I can even put the value here. So right now I'm just talking about the reading cycle. Okay, now what happens next? This is one. Okay, the switch is off right now, so nothing is happening. So as soon as the switch is there, the signal from here is transferred here. Now I can access this particular word, which is word 1. The value in word 1 is can be 0 or 1, since I have given a signal. Now at the output, what I'll receive? I'll receive either a 0 or 1 depending what is stored here in word number 1. So the value of the bit stored in word 1 is going to be out. Similarly, you can have for this. Okay, so now one important thing which you need to realize is that if in order to access 1024 words, you need 1024 wires here. I hope I give you some clarity here, because we are using the switch. Okay, as soon as the switch is closed, the signal is gone here, and when the signal is gone here, then only you get an output, right? Or you can put a value inside it. Okay, so that is a write operation. So we have two operations, read or write. Now this is a 1 bit memory, 1 bit. Okay, now so what I'll say that I have 1024 words. how many words? I have 1024 word, and each word is of 1 bit. So I represent it as like this, 1024 into me 1 each bit. Okay, or I can also represent as 1k into me 1. Please mind, here I have written K and not KB. Now, let's talk about this second memory. Okay, now what is happening here? Again, you see the words are starting from 0 to 1023. So, again, how many words I have in total? Because I'm starting from 0. So, that means in total I have 1024 words. Okay. Now, what difference do you see in this particular figure 2 as compared to figure 1? Okay, the difference being, if you see in word 0, I'm storing 0, 1, 2, 3, 4, 5, 6, 7, and again mind it, I'm starting from 0 and I'm going till 7. That means how many bits you have? You have 8 bits. So right now each of the word is storing an 8 bit. So now if I ask you what is total number of bits which are stored in this particular array, okay, in this particular array, then your answer is going to be, I have how many words? I have 1024 words. Okay. Now, one word is holding 8 bits. So, 1024 words will be holding how many bits? 1024 multiplied by 8. Right? Make sense? So, that means because I know that I can represent 1024 as K and 8 bits as bytes, so I am saying that I am having 1 kilobyte of memory here. Now again the access procedure is same. Again you will be needing how many access lines, and mind you these signals they are coming from outside. So how many signals? So you will be needing 1024 wires to access any one of the word. Okay, because for this word you will have W0 wire, you will have W1 wire, W2 wire, and finally for this is W1024.